In this lesson, we're going to talk about mass spectrometry. Okay, so in mass spectrometry, we're going to talk about the apparatus mass spectrometer. So if you're asking what is the job of mass spectrometer, it tells you about the composition of that sample that you placed, the composition, empirical formula, and the purity. So that's the job of the mass spectrometer. So if you're asking how does it work, let's check it out. So let's start. Now we have three parts in the mass spectrometer. First one, the analyzer. Can you guess what is that part? Mass analyzer, you're right. The last one, detector. You are also right. Okay, so let's start. Let's break it on. So the first part is the ionizer. What happens? It's simple. From the name, you know what will happen. You're right. We have that sample sitting here, which is unknown for now, and we're shooting electrons to it. So we're ionizing it, turning it to a positive ion. So that positive ion will move through that mass analyzer. Let's start. In the mass analyzer, we will have two parts. First thing, the magnetic field and the magnet. Let's talk about their jobs. Magnetic field, their job is to do this, is to just let the ions move. The magnets is to let them turn, okay? So what are those dots? They are the sample they're turning. So the heavier the sample is, you can see the harder for it to take that turn. So you can see it end up here because it's heavy, it cannot take that turn. Then if it's a little bit less heavy, it will be in the middle. But if it's lighter, it's going to take that turn easily. So it will go to down at the bottom. So that's the job of the magnet and the magnetic field. The last part, detector. So can you guess what are the two parts? As you can see, we have some sort of sheets, and here something that's like a box. You're right. That sheets are the electron multiplier. That one is amplified this part, and it tells us what. You're right. It gives us a signal, so it will go to the computer and we get all the analysis. So the electron multiplier, what is its job? Is to this. When electrons just touch that electron multiplier, any electron that touches it, it will spawn, the electron multiplier will spawn electrons and spawn till we reach the last part, and then we're going to be left with the ion hitting that amplifier. I'm going to get that signal to the computer and going to do everything in the computer and get the analysis where we know the composition, what is it, empirical formula, and what is also the purity of that sample. So here we're not going to use a compound, we're going to put an element, which is chlorine, but we want to know which isotope of that chlorine do we have. Is it chlorine 35 or chlorine 37? Now let me remind you what is an isotope if you still remember. You're right, an isotope is just the same element, okay, the same element but with different mass. So it has different atomic mass in it. So chlorine has different isotopes. We have chlorine 34, 35, 36, 37, 38. So you have 5 different isotopes. So I want to know what isotope do we have here in that chlorine sample. So everything, we turn on the mass spectrometer, everything goes on, and the mass spectrometer does its job. So after getting the signal, let's continue after getting that signal. So we want to see what happens next. Let me flip the board here. Okay, so we want to know now what do we have? Okay, that line. So I want to know what do we have here? Like, what isotope do we have of chlorine? You're right. So if you want to know it, it's going to give us a chart. First thing, we're going to get that chart. We're going to have the intensity here, and here we're going to have that atomic weight. So let's start. We're going to put the isotopes 34, 35, 36, 37, 38. Okay, so you can see that there's nothing. We have nothing shown in isotope of 34, chlorine 34, but we have here steep. Okay, you can see that we have a tall line. Then we continue 36, nothing, 37, a little bit, and 38, nothing. So you see, we have only the isotopes that are shown or are given in that sample is 35 and 37. So I want to know which one do we have more, 37 or 35? Let's continue. It's we will use only an equation, which is easy. So let's erase this, and we know that we have the isotopes of 35, 37. We want to know which one do we have here in that sample. So start. We use that equation, which is really simple. Atomic weight equals what? The mass, okay, of mass A, which is for example of chlorine 35 or 37. Let's say 35 multiplied by the abundance of chlorine 35. Okay, so it may not fit, but let's continue. Then we'll add it to the mass of chlorine 37 multiplied by the abundance. Okay, and then we're going to get the answer. If we get the answer, for example 35, the atomic weight is 35, then this is the isotope chlorine 35. But if we get 37, then this is the isotope 37. So it depends if you have more 35 than 37. So that's all about our lesson for today, and I hope you useful. If you want to take a quiz about that lesson, you can just go down to the comment section, okay, and you're going to find the link. I'm going to leave it, but you may not find it right the same second. You find it like after 10 or 15 minutes, so I can upload it and put it in the comment section. So that's all about our lesson for today, and I hope you useful.